Hey guys, this is the Pencast for 11.4 partial conics. We're going to be doing packet 2, problem 40, which is multiple choice, and we are given which is the equation of the graph at the right. And we are given this graph of a partial conic and these 4 or 5 different options here. So first thing to do is analyze the graph. What are we looking for here? So the graph, since it has a radius of 6 going this way, 6 going this way, and 5 going down, and there are no obvious asymptotes that would point to hyperbola, we know that this is a partial ellipse. So we're going to write that down. We're looking for an equation that represents an ellipse. Next thing we can pick off the graph is that we want it to be y equals, because we want the equation to be y equals because the graph is the bottom portion of the ellipse, which means that all of the y values are also going to be negative. So we want a y equals a negative value for b over a. So those are the first 3 things that we can pick up, and we can also find the major axis, which is 12, and the minor axis, which is 10. So with all this information, now we can start looking at our options. So right away, we can cross out B. So B is not correct because that equation would give us the full conic, not the partial, because it has both x and y on the same side of the equation. This is the standard form of a conic, so it is wrong because it is a full conic. Next, right away, we can eliminate C, because C is an x equals equation. And we determined before, because it's the bottom half of the ellipse, we want a y equals equation. So this x is not right, or C is not right, because it's an x equals, and we want the bottom half. So bottom half. Okay? And last, right away, we can eliminate E. We can eliminate E because E gives us the graph of a hyperbola. Because if we move this x over to the other side, it's going to be negative, and then you've got a positive y with a negative x, and then you multiply by the negative 36, and you get the positive x with the negative y. Either way, it's a hyperbola, and we know that our graph is not a hyperbola, because if it was, it would have asymptotes. So a hyperbola, because no asymptotes. So we are left with A and C. Now if we look at A, and if we rearrange it, we find that A can also be written as like this. Notice that there is no scaling of x and y in the equation. So, we know that the A equation shows us a circle, which is not good because we're looking for an ellipse. So A is now out of the picture, and we're only left with D. So D must be the correct answer, but let's see why. So D is the correct answer because if you multiply it back, you get a negative y that is squared, and then you add the x, so we've got positive x and positive y squared, so that follows. And then we also have the correct major and minor axes. So if we move this around, we know it's an ellipse because x is negative here, and this is positive, so it won't change the signs at all. And we know that this value is, because it's y equals, it's going to be the b over a. So the y direction axis, the y-axis value over the x-axis value, which follows with our graph that we were given. So 6 in the x direction, 6 down here, and 5 in the y direction, 5 down here. And so, to recap, we have which we determined from the graph that we wanted a partial ellipse. We want it to be y equals because it's the bottom half, which also follows with the fact that we want it to be negative. And we found the major axis was 12 and the minor axis was 10. A was wrong because it's a circle and it has no vertical or horizontal scaling. B was wrong because that represents a full conic and we only want the bottom half of this ellipse. C was wrong because it is an x equals equation, and that would give us the right or left half when we are looking for the top and bottom half. And E was wrong because this equation is a hyperbola and there are no asymptotes given in our original graph. So we have to conclude on D, which is in fact an ellipse and is this ellipse. Okay, for more information, go see the other 11.1 through 3 resources, and have a great evening. Happy studying!